what do you do with 4 Raspberry Pi 5s? Well, if you're me, then you buy them with the idea of making them a cool AI cluster, then only after buying an AI accelerator for each of them, you realize that these aren't designed to run LLMs, so you just wasted a bunch of money. Well, I used this opportunity to spin up a new Pi cluster, except that this time, instead of Kubernetes, we're gonna try out Docker Swarm. And after using it for a bit, I really don't understand why it gets so much hate. Let's talk about it. So after a disappointment of having a failed project, I was determined to get some use out of these Pis. I guess I should mention that the Pis that I'm using are the 8GB models, and I also have them equipped with 256GB NVMe boot drives. Except for on the 4th one, but we'll talk about that. Or I could just mention it now. So these 3 have NVMe drives, and the 4th one still has the AI accelerator on it in case I want to use it down the road. So yeah, I mean, there's not really much to talk about here in terms of the hardware. I put them in my rack using this 4-bay little 1U mount from UC-tronics, I don't know how to say it. And I'm powering them using these little PoE splitters that takes a PoE signal and splits that into network and USB-C power plugs. Those can each do 20 watts, which is a little bit less than the standard Raspberry Pi 5 power supply, but I'm not pushing these to the limit, and after a few months of use, I've experienced no issues. All right, the whole point of this video is basically the software. Why did I choose Docker Swarm? Well, for 2 reasons. One is that I've never used Swarm in my life, and I like learning new things. Hell, I'll try anything twice. And 2 is that the alternative, Kubernetes, has left a bad taste in my mouth since I started using it in my lab probably 2 years ago. I wouldn't say it's bad. I mean, Kubernetes is amazing. I just don't think it's amazing for a home lab. When you're hosting a bunch of services at high scale and have the resources to support a Kubernetes system, then cool. But when you just have a handful of stuff running on it, the upkeep and overhead of maintaining a Kubernetes cluster just isn't something I want to deal with after coming home from my 9 to 5. So does Docker Swarm fare any better? Well, yes, it's much easier to spin up. Deploying services is familiar if you've used Docker, and it's easier to migrate over existing containers. However, it is not perfect. While it is more simple than Kubernetes, it does lack some features that prevent it from being a popular solution for cluster use. Let's start with the setup. You'll first want to have Docker installed on all the devices you want to cluster. For the most part, that's just a simple command depending on which operating system you're on. Then you'll want to navigate to any of the nodes that you'll designate as a manager node and run a single command, Docker Swarm init, advertise address, and then the IP of that node. And that's it. Docker Swarm has been initialized on that node. There are more flags that you can set depending on how you want your cluster to function, but for a simple vanilla setup, that's all you need. Then on each of your other nodes, you'll run the command that it gives you from the previous step to join each of those nodes to the cluster. These nodes will join as worker nodes, meaning they're just there to pick up services, not to delegate. And promoting a node from worker to manager is as simple as using the command docker node promote and the node ID, which can be found by running docker node ls. Personally, I have nodes 1, 2, and 3 as manager nodes, and node 4 set as a worker, but I also have applied a taint to it, meaning that it is by far the kinkiest node. In reality, it just means that this node won't pick up any work. I set this because I wanted a Pi in my rack that could run stuff outside of the cluster, but I could still have it pick up jobs if I need it in a pinch. And there you go, your Docker Swarm cluster is up and running. It's actually just a basic command on each device, insanely easy. Now you're free to use whatever Docker UI you'd like, but y'all know that I'm going with Portainer. They have documentation on how to do this in Swarm, which pretty much boils down to just downloading a YAML and applying that as a stack. The end. At that point, you can log into Portainer as you would on a normal Docker deployment. The only difference you'll really notice is the Swarm cluster options that give you some general info about the setup. And the way Swarm natively works is that you should be able to hit any of the manager node IPs to access the services, assuming they're using the general Ingress network. You can get more specific with your network, obviously, but that's the default functionality. Now you're free to go ahead and deploy Docker containers as you would normally, but if you want the benefits of the Swarm cluster, you'll want to deploy them as services rather than containers. Basically the same thing, except that when you deploy a service, Docker knows, hey, this is a Swarm thing, so let's treat it as such. It also lets you provide specific parameters like how many replicas of that service you want running, cluster stuff. This is easily done via Docker Compose files, and honestly, nothing really has to change other than specifying that template as a Swarm template rather than standalone in the Portainer UI. And then again, obviously, you can do this all through the CLI if you don't want to use Portainer, but y'all know I'm a Portainer shill, so that's what I use. One recommendation I have is to create an NFS share for your cluster to have shared storage among your nodes. Swarm doesn't have any fancy built-in HA storage like Longhorn with K3s, so if you want your cluster to actually be able to migrate services from different nodes, make sure that you use some kind of shared storage. I recommend NFS specifically since it's less of a nightmare with permissions than Samba. You can either mount them to a local directory on each of your nodes and pass in a binding mount to each of your services, or you can create NFS volumes. Each has their pros and cons, but I went with the local mount and binds because it just felt a bit cleaner to me. Then deploying services to your cluster is as simple as applying those YAMLs. Once you do this, the services specified in your file or stack are evenly distributed over the cluster. Similar to Kubernetes, you can create custom tags on nodes to specify where certain workloads should go. For my setup, I didn't do that because it was pretty unnecessary. Of course, regular old basic services like Nginx, file browser, Schlink, low requirement stuff are going to run perfectly fine on here. But what about hosting Plex in Swarm? Well, it works as you'd expect. It's not like Plex really benefits from scalability since it's a standalone service where the whole front end and back end are all built into one. So when you spin up multiple versions of that using shared storage, it's not really going to play too nicely with two instances. Now, certain things do scale well, like static sites, front end UIs, and APIs. For example, Ghost, a website hosting stack that deploys a database service and a front-end service separately. Since we only want to have a single database service running, that's fine, but we can actually scale the front end to deploy multiple times to account for heavy traffic. Not that anyone is hitting this, but it's cool to play with. Now, there are ways to scale and create highly available databases, obviously. I know Techno-Tim was recently doing this in his local K3s cluster, but that's beyond what I want to do and what I'm showing here today. So yeah, we have a scalable cluster now with shared resources. Pretty cool, but what about the most important features of clusters? High availability. What happens if one of my nodes goes down? In a cluster, we'd expect those services to automatically be migrated. Well, good news, Swarm does that, but it's not perfect. In my example, I took down node 2 and monitored the cluster to see what would happen. Swarm did in fact migrate the services evenly to nodes 1 and 3, even though Portainer's UI wasn't showing this until I brought node 2 back up. But I'm marking that as a Portainer issue, not a Swarm issue. Great, right? Well, yeah, but what happens when I bring node 2 back up? Surely my services will rebalance to use it, right? No, Swarm doesn't natively work like that. It won't stop services and migrate them unless it is required to. So you'd have to scale up those to make use of the new node or force update the service manually. Could you create some kind of script or automation for this? Probably. Should this be a native feature? Also probably. And just for fun, I brought up my node 4 and removed its taint, then scaled up my Ghost to 4 replicas just to see if it would spin that 4th one up on node 4 as you'd expect, and it did. Neat. So should you use Docker Swarm? Well, maybe. I don't know your use case. I'd say if you're looking to have a simple, low maintenance, somewhat highly available cluster for your Docker services in your home lab, then yeah, go for it. If you're looking for something more robust with more sophisticated clustering features built in and hate your sanity, then maybe look into Kubernetes. I really just wanted to try out Swarm because I only ever see people complain about it. I didn't even expect to make a video about it considering how negative the connotation is around it, but I was pleasantly surprised. Like I mentioned, I'm not suggesting this for complex systems, but for a few machines in your home lab, I'd actually recommend giving Swarm a try. Remember, this is a PSA. Not everything in your home lab needs to be the best or the most optimal or enterprise level. It just needs to work for you. Let me know what you think or what your experience with Swarm has been down in the comments. That's all I have for this one. If you liked it, then drop a like and subscribe if you want to see more. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my highly available swarm cluster that runs all of my services to perfection. Y'all are the best. And if you're still watching, you're Seth. Thank you so much, and I'll see you in the next one.